In a previous video, we explored the idea of patterning slots within the boundary. I came to the conclusion that the top-down extrude approach might not be the best idea, as we were not able to properly pattern the fillets. I think I may have found a way to make that approach viable. I want to thank Imang for bringing my attention to the possibility of using a rule fillet. We have a series of cuts here produced by a rectangular pattern of extrudes. With this sketch, I performed an extrude to fill in the areas where I do not need the pattern. The reason for doing this is that we simply could not find a way to force the pattern slots to adjust their lengths according to the circular boundary. If we had a full round fillet to this face, and attempt to use a rectangular pattern with the same spacing, we quickly find out that we are not able to pattern the fillets properly, even by adjusting the compute options. I think the main reason is that these faces are not part of a repeating pattern. The only option would be to select each face individually to fillet. This would of course be very tedious. More importantly, if the pattern quantity is increased, the additional instances will not have fillets implemented on them. The use of rule fillets solves both of these issues. In the fillet command, set type to rule fillet. For rule, select all edges. At this point, we need to either select a face or a feature. It wouldn't make sense to select individual faces, as that would provide no advantage over the typical fillet. Instead, we are going to select the extrude that was used to perform the filling in. The reason we are selecting this feature is because this was the feature that created the end faces. Let's select this from the timeline. For topology, we will need to select fillets only. We will need to adjust the radius to be half of the width of the slot to achieve the full round fillet. Let's take a moment to understand the difference between fillets and rounds. An easy way of differentiating between the two is that rounds remove material, while fillets add material. If we change the topology option to rounds only, the command will look out for all external corners to remove material to smooth them off. In the case of fillets, the command will look out for internal corners to add material. The fact that the command automatically seeks out internal corners is what makes this so powerful. So we have managed to apply these fillets without the need for multiple selections. Let's test this out by increasing the pattern quantity. When you increase the instance quantity, the rule fillet command will recalculate, find all the new internal corners, and apply the fillets accordingly. Let's go back into the fillet command and remove the current selection. We can also choose the seed extrude cut and the pattern. This gives us the same result. Let's remove the selection and try using the between faces or features option as the rule. With this option, understanding what to choose can be rather tricky. We have to think about what are the features that interacted to form the end faces. The fill-in extrude is one of them. So let's select that as a first feature. Click on the select box for the second set. The seed extruded cuts and the pattern definitely played a part in forming the end faces. So select them as the second set. Check to make sure that you have two features selected in the second set. This gives the same result. The command definitely allows for a certain degree of flexibility. I would encourage you to experiment with the different selection options. Just as a side note, if you use a normal fillet, and choose a fill-in extrude, this will not work. This is because a normal fillet does not have the ability to differentiate between internal and external corners. Hope that this has been helpful. I will see you in the next one.